All right, so in this video, we're going to look at how to apply Simpson's rule to evaluating an integral. And in this case, it's very similar to the formula for the trapezoidal rule, although there are a couple of specific differences. In the trapezoidal rule, our coefficient out front has a 2n in the denominator. This one has a 3n. And the other difference is that in the trapezoidal rule, all the coefficients except the 2 on the ends are 2's. In Simpson's rule, it alternates 4, 2, 4, 2, 4, 2, 4, and then the 1's on the end. Now, one thing about the Simpson's rule that is different than the trapezoidal rule is that in the trapezoidal rule, you can use any integer value of n, any counting number. So it can be odd or it can be even. In Simpson's rule, n has to be even or the formula is not going to work. So that is one limitation on this. But Simpson's rule is more accurate than trapezoidal rule. So let's identify our values. We see n here is specified as being 6. And we're going to say A is 3 and B is 7. Those are our limits of integration. And so we can put our integral together to do our estimate. And again, I picked log x here, not because it's not something that we can't do by hand and get exact values for, but just so that we have a relatively simple function to work with. Things get much stickier when we try to put them into the calculator when the formulas are very complicated. Certainly they still work. This method still works, but you do have to be more careful about exactly how you put things in the calculator with your parentheses and so forth. Now, our coefficient out front, b minus a over 3n. This is going to be 4 over 18. So 2 over 9 is what it's going to reduce to. And then in our formula, we're going to have log of the first value. And then we need to figure out what the next step is going to be. So recall that h, or delta x, the number of the values in between our observations, is going to be b minus a over n. So in this case, that's going to be 7 minus 3 over 6. Nope. 7 minus 3 over 6, or 4 over 6, which is 2/3. So as we apply these stages, these steps, we should use fractions, not decimals, when we put this into the calculator. One of the issues is going to be rounding, and if you don't write out all the decimals, or you don't use the fractions, if you round too much as you're going through the process, then you are going to get your accuracy is going to go way down because you're pre-rounding, and so you're actually going to kill the value of using Simpson's rule at all. So x of 0 is our first value, but then every value after that is going to be 2/3 more. So 3 is 9/3 plus 2/3 is 11/3. And then x2 is going to be 2/3 more, so 13/3. And then x3 is going to be, add 2 more, 15/3, which is 5. And then x4. And if you have weird numbers like this, it is useful to write these out. 17/3. x5 is 19/3. And then when you get to n, x sub n, then in this case, you'll get 21/3, which is 7, which is your final value. So now if we go back to our formula, the second term is going to be 4 log of 11 over 3. And then 2 log 13 over 3, and then 4 log 5, and then 2 log 17 over 3, and then 4 log 19 over 3, and then finally just log of 7. And so now we have to put that in our calculator. Be careful with your parentheses. Log 3, 4 log 11 over 3, plus 2 log 13 over 3, plus 4 log 5, plus 2 log 17 divided by 3. After every log, you're going to have to, after you put in your number, close the parentheses, and then log 7 at the end. And then we said that this was going to be 4 over 18 or 2 over 9. So times 2 over 9. And we're going to get 6.32546.423 ... And again, you can do this numerical integration trick in your calculator. In the TI, it's the FN int, it's math 9. And it is essentially doing this numerical integration, but it's doing it with much more n than we're using. And the value that that's giving us is 6.325534. So this is much closer to the true value than the trapezoidal rule was, and we're using fewer n, which is, again, this is why Simpson's rule is great, because it is less work for more accuracy.